Hello, I am Mr. Rogers, and you're watching the video notes on a brand new chapter. Section 2-1 in our new books will be Sound and Light. And in this chapter, guys, we're talking about, obviously, sound is going to be our biggest focus. And in this first section, we want to talk about how sound is actually carried. These different, like, waves. We're going to talk about a wave. Nice, gentle wave. Not like this, not the wave you would see like in a beauty pageant. But a wave, like a sound wave or electromagnetic wave, any type of wave, simply put, is a disturbance that transfers energy from one place to another place, so from place to place. They carry energy, and energy in science is the ability to do work. So it can carry, move, push, transfer heat. That'd be energy. And the waves we're going to focus on today mostly all carried through something. We call that a medium. A medium is what a wave travels through. So sound waves right now, the sound waves are traveling through air as they go to the microphone. And these waves we're going to focus on typically are created by a disturbance, not in the force, but a disturbance that causes these mediums to vibrate is what's going to happen. And we're going to focus on two types of waves. We have the classic wave, which is a transverse wave. So a transverse wave, the waves move at right angles to the direction in which the wave was traveling, so we kind of think of that typical wave. And those waves have the crest, the high points, and they have the troughs, they have the low points. And that's more the typical wave you think of a wave, like a wave in the oceans going up and down. But that is not how sound waves travel. Sound waves travel on longitudinal waves. Longitudinal, nice new big word there for you. And longitudinal waves, what happens here, the particles of the wave, they're moving kind of back and forth. So we got to think of it more like a spring, how it's going to compress and expand, compress and expand. So it's not going up and down. It's more going, think like an accordion style would be the way to look at it. That's how these waves move, how they travel and carry energy from place to place. And there's two kind of major parts. There's not a crest or a trough, but we have what are called compressions. This would be parts of the wave where the particles are really pressed together. And the other parts are the rarefaction. These are the parts where the particles are very far apart or spread out. And our third type, we'll talk more about when we get to earthquakes later in the year, are surface waves. And these kind of combine transverse and longitudinal waves, and again, they're found in earthquakes. But we're going to focus a lot on these longitudinal waves. So our two types of waves, and here's a kind of a visual of our two types of waves. So our typical transverse wave, you can see the up and down motion, think about a wave as we think of that transverse wave. But in sound, like that spring there, it's going to be more of a longitudinal wave. So we have the parts that compress. You can see here the compressions where they really part together, and we have the rarefaction where it's more spread out, where the parts are more rare. And so in a transverse wave, here's a transverse wave in motion right now, we have two kind of major parts to look at. The crest, that's the top of the wave, and the trough. The trough is the bottom of the wave. And there's some other kind of key factors we're going to look at. One is called the amplitude. The amplitude is kind of how high or low the crest and trough are away from that dotted line, which would be like the rest position. And the other thing is what's called the wavelength. And that's from any two parts of the wave. So if I picked out the crest, two different crests of waves, so the top of the wave and two different parts, the distance between that would be the wavelength. And those are kind of major parts of a transverse wave. So on a longitudinal wave, it looks a little bit different. We don't have a crest and a trough. We have the rarefactions in the compressions. So the compressions, again, close together. The rarefactions are where it's spread out. And the wavelength would be like from one compression to another compression. That'd be the wavelength, how long it is between those two places. Excuse me. And the amplitude would be, again, how far away are those would be the amplitude. So when we look about sound, this all goes back to sound. That same type of wave, that longitudinal wave, you got to think about these are air particles right here. And these air particles, again, sound's going to travel through them as a longitudinal wave. So it's going to be compressed. You can see those parts compress and expand away. And so that's how sound is traveling through the air or any other medium that it travels through. So we're going to stop here, guys. I want to give you just a few basics of these parts of waves, and we'll move on from there. Thank you for watching today. Bye.